Welcome to our webinar on industrial protocols. My name is Dyke Gomez, application engineer here at ICP DAS USA. Today we're going to discuss a topic that is fundamental to every automated facility, industrial communication. This presentation provides an overview of three of the most common protocols you'll encounter: Modbus RTU, Profibus, and EtherNet IP. Here's our agenda for today. This presentation on industrial communication protocols will begin by exploring why protocols matter in modern automation. It will then offer a deep dive into Modbus RTU versus Modbus TCP, followed by an explanation of Ethernet IP and Profibus. This session will also cover troubleshooting communication failures and include a case study spotlight, concluding with a Q&A session. ICP DAS was founded in 1993 in Hsinchu, Taiwan, specializing in industrial automation and data acquisition solutions. In 2001, ICP DAS USA was established to expand our global presence and better serve the North and South American markets. We are committed to providing fast service, free technical support, quick shipping, and reliable products backed by a solid warranty. Our products are RoHS compliant and ISO 9001-15 certified, ensuring the highest quality standards for industrial applications. We provide solutions for each of the topics we will discuss today. Industrial protocols are like common languages that let machines and factories talk to each other reliably. They are key for automation, making sure different equipment can work together smoothly. They help with everything from reading sensors to controlling motors and are essential for the industrial Internet of Things. These rules tell different parts of a system how to understand each other's commands and information, building the foundation for connected factory setups. There are many types of these languages to fit different industry needs, which helps factories use various machines together. Modbus is an old but very common open language for industrial devices, created by Modicon in 1979. It uses a simple main and servant setup to send data, which is organized into basic on-off signals and numerical values. This simplicity, combined with its open availability and ability to work on both older serial connections and modern internet networks, has made it a fundamental protocol. Modbus RTU is a serial communication method for industrial machines that uses a master-slave or client-server approach. The master device sends messages to specific slave devices. Each message has a unique address for the slave it wants to talk to and a function code that tells the slave what to do, like read data or change a setting. The chosen slave then does what's asked and sends a reply back. This communication uses compact binary code over wires like RS-485, making it efficient and good at catching errors. It's a straightforward, one way at a time, and very dependable way to exchange data in industrial settings. A Modbus register table is like a map for a Modbus device. It shows you exactly where to find specific data inside the device, like a temperature reading or if something is turned on or off, what each piece of data represents. The company that made the device creates this map. They decide what information the device can share, give each piece of data its own unique spot or address, and tell you if you can only look at it or also change it. You'll also find this map in the device's instruction book. Here's an example from one of our Modbus RTU data acquisition modules. Modbus messages are built as structured byte sequences. A request from the master begins with the slave's address, followed by a function code, then specifies the data's starting address and quantity, all ending with an error checking CRC. The slave then responds with its address, the function code, a byte count, the requested data, and its own CRC, ensuring reliable communication. Modbus TCP is based upon Modbus RTU, going from a serial protocol to be able to be used on standard Ethernet networks. Enabling reliable data exchange between industrial devices over TCP IP uses existing Ethernet equipment for higher speeds and scalability, establishing client-server connections via IP addresses. Modbus TCP offers several key benefits over Modbus RTU, making it a popular choice in modern industrial settings. It runs on common Ethernet infrastructure, allowing for higher speeds, longer distances, and easier integration with existing IT networks. Ethernet's higher bandwidth enables faster data transfer and supports more devices simultaneously, improving efficiency for larger systems. By using TCP/IP, it benefits from built-in error checking, ordered packet delivery, and retransmission capabilities, ensuring data integrity. It is still an open protocol. It's widely supported by various manufacturers, offering flexibility in device selection and system design. Modbus RTU is a serial protocol designed for simpler direct wiring. In contrast, Modbus TCP is a network protocol over Ethernet and TCP/IP for faster communication and easier scalability. It eliminates the need for an explicit CRC within the Modbus message itself, as the underlying TCP/IP layers handle error checking. Instead, Modbus TCP frames start with a Modbus application protocol header, seen here, which provides connection and routing information for Ethernet-based communication. Modbus RTU uses serial communication, while Modbus TCP runs over Ethernet. RTU uses slave IDs for device identification, while TCP relies on IP addresses. RTU typically operates in a master-slave model, while TCP offers more flexible client-server model, allowing multiple clients and servers. Modbus RTU is much slower, typically from 9.6 to 115.2 kilobytes per second, limited by serial baud rates. Modbus TCP is significantly faster with speeds up to 1 gigabit per second. RTU is limited to about 1.2 kilometers or 4,000 feet without repeaters, whereas TCP offers theoretically unlimited distances via routers and the internet. RTU messages contain address, function code, data, and a CRC for error checking. TCP messages use an MBAP header, function code, and data, as TCP/IP handles error checking. RTU is generally lower cost and simpler to set up due to basic wiring. TCP has a generally higher cost due to more complex cabling and more complex setup involving IP addressing. Modbus RTU is ideal for legacy systems, simple field devices, point-to-point connections, and cost-sensitive applications, especially in harsh environments over shorter distances. Modbus TCP is best for modern systems, high-speed data, large-scale systems, and applications requiring remote access. Profibus, or Process Field Bus, originated in 1987 from a German government initiative aimed at standardizing industrial communication. Developed collaboratively by 21 companies, led by Siemens, it quickly became a core component of Siemens' somatic automation systems, gaining global prominence. In 1991, Profibus achieved recognition as part of the EN 50170 European Field Bus Standard, solidifying its importance. The two main variations are Profibus DP, tailored for a high-speed data exchange with field devices, and Profibus PA, specifically designed for process automation hazardous environments. It is especially catered toward fast data exchange between automation devices. Profibus is a robust industrial communication protocol with two main versions. Profibus DP, designed for high-speed data exchange up to 12 megabits per second, and Profibus PA, which is intrinsically safe for use in hazardous environments. It supports multiple masters using a token ring method and is vital in complex automation systems such as automotive robotics due to its excellent deterministic performance, crucial for critical applications. Implementing Profibus does require specialized cabling and technical expertise. Profibus DP is specifically optimized for very high-speed data transfer between central controllers and their connected I/O, enabling fast and efficient control of field devices. The physical layer for Profibus DP typically utilizes RS-485 twisted pair cable. Often identifiable by its purple color, this cabling supports a range of data rates from 9.6 kilobits per second up to 12 megabits per second. The shorter the cable, the faster speeds can go, and vice versa. This physical infrastructure ensures the reliable data exchange. Profibus DP communication primarily relies on master polling, where a master device initiates contact by requesting data from connected slave devices. These slaves then exchange data by responding with their information only. This process results in cyclic updates where communication occurs rapidly within milliseconds, ensuring real-time control essential for industrial processes. This example demonstrates a Siemens PLC acting as a Profibus DP master, controlling and monitoring a remote I/O station. It details the steps of configuring the master, transferring digital outputs, and collecting digital and analog inputs for processing. This slide illustrates a practical example of Profibus DP communication for controlling a variable frequency drive. It shows how a Siemens S7-400 PLC exchanges both control commands and status information with a VFD in real time. The PLC sends commands such as a speed set point and control word. In return, the VFD provides status updates like its actual speed, status word, and motor current. Profibus DP continues to be relevant in today's industrial environments. It's well known for its reliability, offering consistent and predictable performance for mission-critical factory operations. It's already widely adopted. There's a strong support ecosystem in place, which makes integration and troubleshooting easier. It's also a cost-effective choice compared to many of the newer network technologies. ICP DAS USA offers a full line of Profibus I/O modules and communication solutions to help bridge legacy systems with modern automation needs. Now let's move on to the final protocol for today, EtherNet IP. EtherNet IP is an application layer protocol designed for industrial automation. It is built upon standard Ethernet and TCP IP protocols, creating a network architecture capable of handling control, information, and safety data. Ethernet IP uses the Common Industrial Protocol to establish consistent ways of organizing data and communicating. This ensures that devices from different manufacturers can work together seamlessly within the industrial environment. Now let's look at some of the key aspects that make Ethernet IP stand out. It enables the integration of multiple complex networks, all while maintaining extremely high communication speeds, far exceeding what traditional serial protocols can offer. On top of that, it's highly scalable, making it just as effective for small local setups as it is for large, globally distributed systems. Ethernet IP supports two types of communication, implicit and explicit messaging. Implicit messaging is used for fast, time-critical data exchange, perfect for real-time control between devices like PLCs and I/O modules. Explicit messaging, on the other hand, is used for non-time sensitive data, such as configuration or diagnostics. Both play crucial roles, and understanding how they work together is key when designing a reliable and efficient automation system using Ethernet IP. To sum up the advantages of Ethernet IP, it's a unified networking solution that streamlines communication across devices. It operates at much higher speeds than older serial protocols, which helps reduce latency and boost performance. And perhaps most importantly, it's incredibly scalable. You can use it in everything from small setups to large, complex industrial systems. Here in the United States, Ethernet IP is most associated with Rockwell Automation's Allen Bradley PLCs. Ethernet IP is the primary protocol offered on their large array of PLCs. Rockwell is a founding member of ODVA and has been instrumental in advancing the protocol and its features. Their most popular control and Compact Logix PLC offer native support for Ethernet IP, though some offer optional secondary choices like Modbus TCP. Ethernet IP is the main protocol. ICP DAS USA offers some easy-to-add, cost-effective remote I/O modules compatible with Rockwell's line of PLC and Modbus gateways to allow for easy sharing of data from Rockwell PLCs to third-party devices. In this presentation, we covered 3 of the most common protocols used in industrial automation. While there is no one-size-fits-all solution, most times the protocol of choosing is based upon PLC selection. Siemens and Profibus reign supreme in most European countries. Rockwell and EtherNet IP are very popular in the United States, and the widely used Modbus protocol allow industrial equipment to communicate and control applications. ICP DAS USA offers a large product offering in all 3 of these protocols. We have remote I/O modules for each to add I/O points and the ability to minimize wiring of sensor back to the central PLC. We offer gateways which help devices communicate to each other when the protocols do not match. If you have an application using one of these protocols, PLCs, or any automation task, please feel free to contact us and discuss your application with our sales and technical support team. This concludes our industrial protocols presentation. Our contact information is shown here. Enjoy the rest of your day. Thank you.